Okay, in this example it says determine the volume of a gas at STP if 600.0 mils is collected over water at 50.00 degrees Celsius and 780.0 torr. What I want you to see here is we've got a P1 V1 T1 equals P2 V P1 V1 over T1 equals P2 V2 over T2 problem because we've got two sets of conditions. We've got this set of conditions where we've got the 600 mils collected over water at that temperature and that pressure, and we've got volume of a gas at STP. Two separate sets of conditions telling us we need to use these sets of equations. Alright, so when we're doing this, I always like to write these out. You've got P1, V1, T1, and over here I'll write P2, V2, and T2. And what I'll do is I'll do P1, V1, and T1 as being these sets of conditions since the answer is going to be over here. And what we've got is volume of 600.0 mils. And the pressure is going to be, well, it says 780.0 torr, but that is collected over water. Now, whenever we see collected over water, that means we're going to have to take the pressure of the water into account. Now, if you remember what our Dalton's law of partial pressures says, is that P total equals P gas plus pH2O. So we need the pressure of the gas here, so the pressure of the gas is going to be P total, which is given to us, minus the pressure of the water. Now the pressure of the water is the vapor pressure of the water, which we're going to find by looking at the vapor pressure of water chart. Now at 50 degrees, that's the temperature we're given, it's 92.5 millimeters of mercury. So I'm going to take that into account right now. And what I'm going to do is I'm going to say, well, P gas is P total minus P water. That's going to be 92.5 millimeters of mercury, which I'm going to convert to torr. Millimeters of mercury and torr are one and the same. And that's going to come out to be 687.5 torr. Alright, so that's going to be the pressure once we take out the pressure of the water. Temperature 1 here is given as 50 degrees, 50.00 degrees Celsius, which we will convert to Kelvin, and because we're given 273 as our conversion factor, we can see that we're going to get 323 K, and the number of significant figures here is given by the number of decimal places, 2 decimal places, 0 decimal places, 0 decimal places. Likewise over here we had 1 decimal place and 1 decimal place, so the answer came out to 1 decimal place. Remember, this is a subtraction, this is an addition, that's why we're using decimal places to decide our significant figures for these. And we have to figure these out because we're going to use a division multiplication business later on down here, so we have to figure out these significant figures right off the bat. Alright, so going back to here, we've got our volume which we're trying to find, and the pressure is given as STP, so we're talking about 1 atmosphere, which I'm just going to go ahead and convert to 760 torr automatically, because we've got torr over here, and the temperature 2 here is going to be 273 K. Now remember, STP is 1 atmosphere, 0 degrees Celsius, which is 760 torr and 273 kelvins. Alright, so now we're in a position to go ahead and figure out our problem. We've got P1 V1 over T1 equals P2 V2 over T2. We're looking for V2, so I'm going to isolate that. It's going to be P1 V1 and then times T2 over T1 and P2. So what I've done here is I've taken the T2 up to the top and I've taken the P2 down to the bottom. That's to isolate V2. That's just a multiplication and division thing so that I can manipulate the equation to get what I want. Now I can go ahead and stick in the pressures and volumes, 687.5 torr. We've got the volume 1, which is 600.0 mils. We've got temperature 2, which is 273 K. We've got temperature 1, which is 323 K. And we've got pressure 2, which is 760 torr. So that's going to give us our answer, which comes out to be 459 milliliters, and that's got 3 significant figures because this one has 3 significant figures. I also want you to see how all the units cancel for this one as well.